In this video, we're going to be doing more work with the trig identities that we've been studying. Let's start with the basic definition of an identity. So I stole this straight from the Wikipedia page, but it does a really good job of explaining what that is. So essentially, if you have A and B and they're both functions, it's an identity if A and B define the same function. So for example, this thing highlighted in green, if I have a plus b all squared, that gives me my a squared plus 2ab plus b squared if I FOILed that out or if I expanded that. Another identity, or a trig identity, is our sine squared theta plus cosine squared theta equals 1, which we can prove using the Pythagorean theorem and information about the unit circle. And to remind you of the identities that we've looked at so far, our reciprocal identities, we have cosecant, secant, and cotangent, and then we also have the quotient identities of tan and cotan, and then our Pythagorean identities, which come from this guy right here, and then our even and odd identities, which come from the unit circle as well. So let's get straight into it. Let's take a basic fraction here and let's simplify it. So I have cotan over cosecant. Now, my tip here is that it is usually helpful to rewrite these things in terms of sine and cosine. So I know cotan is the same as cosine theta over sine theta, and cosecant of theta is the same as saying 1 over sine theta. And using what I know about algebra, I can cancel these here, and so I'm just left with cosine of theta over 1 or cosine of theta. So that's a really nice one that simplifies down to a trig expression that's either sine or cosine. So a phrase that we often see when we work with trig identities is something called establish the identity, which just means that take whatever's on the left-hand side of the equation, whatever's on the right, and make them look the same, however you need to do that. My tip is to start with the most complicated one, usually the one on the left, and turn it into the thing on the right. So really you only, most of the time, need to manipulate one side of this. So I'm going to look at my left-hand side. I know cosecant of theta is 1 over sine theta, and tan is sine theta over cosine theta, so I'm going to write that. So what I'm going to do with these things is I'm going to cross-cancel my sines, and I get 1 over cosine theta is equal to secant of theta, and 1 over cosine is the same as secant. So they are identities of one another. Or what I've done here is I've established the identity. So let's take a look at another example. What I have here is 1 plus tan theta all over 1 plus cotan of theta equals tan of theta. So again, I'm going to take the more complicated side, which is the left-hand side, and I'm going to manipulate that. So the first thing I'm actually going to do is I'm going to rewrite this cotan of theta as 1 over tan of theta. Now I chose to leave this in terms of tan instead of cos over sine is because all of these things, or well, these two things here are talking about tan. So that's all I really need to do. I don't need to go that extra step and turn that into cosine and sine. So I'm going to turn this denominator here into something all over tan of theta. So that means that I need to multiply this by tan of theta over tan of theta. Let's see what I get. So now I have something that still looks a little complicated, but it's actually a step closer to where I want to be. And where that is I'm going to cancel out this denominator by multiplying my numerator by its reciprocal. So that will cancel out. And what I notice here is this is like saying this fraction multiplied by this all over 1, and these two are the same, so that's like saying that equals tan theta, and that's the same as that. So I established that identity. Alright, one more example. So I've got tan theta plus cotan theta all over cosecant theta, secant theta equals 1. Now, like the last one, I was trying to get to tan of theta. This time I'm trying to get to 1. So I'm actually going to rewrite all of these things in terms of sine and cosine and see what I get. Alright, so I have everything in terms of sine and cosine, and I've got a fraction on top and a fraction on bottom. You're going to be tempted to cancel these, but you can't. That's buffoonery, because that's a plus sign in the middle, so I need to have a common denominator there, so I'm going to multiply by sine theta over sine theta here, and cos theta over cos theta here, and this guy will just become 1 over sine theta cos theta, which incidentally is the same denominator I'm going to have here. So let's rewrite this. So I get sine squared theta plus cosine squared theta all over sine theta cos theta all over 1 over sine theta cos theta. So the beautiful thing here, that cancels, so I'm left with this over this, and this is a Pythagorean identity. That equals 1, and if that's all over 1, that's going to equal 1. So I've established the identity. So that's going to do it for this video. Thanks for watching.